What's up, everyone? This is LeetCode 226 Invert binary tree. We've done this problem in Python, but we're doing it in C++ now. So, yeah, we have the root of a binary tree. We have to invert it and then return its root. So, as you can look at by the illustration, inverting it really just means swapping every node, every child of a given node, but basically swapping the child nodes, right? And so the end result really is like almost symmetrical down the center. Not symmetrical down the center, sorry, but like imagine taking a mirror, right? Everything on the left here should be on the right as a final result. Everything on the right should be on the left for the final result. So not symmetrical, but you get what I mean. Like it's you almost mirror the tree down the middle, and everything on the left side should be on the right side for the end result of basically what you're returning. It doesn't help that much with coming up with the solution because you're really just doing swapping, but I'm just giving you kind of an idea of what they mean by invert the tree, right? But anyways, so we're gonna do this by recursively calling this function. So we're given the root node, right? So we're gonna say invert tree dot left, invert tree dot right, and we have to return the root. Okay, now we need to do something when we enter this this function again, right? So first of all, let's handle the base case. So we're gonna say if root is equal to null, we can just return 0. Okay, now here is where we basically have to do the swapping, and then this is just the recursion, right? So if we have root.left is equal to, let's say, 1, root.right is equal to 2, the problem when we do root.left is equal to root.right, root.left. So when we set let me do this. So when we set root.left is equal to root.right, root.left becomes 2, right? And root.right should be equal to root.left. Well, we're setting that equal to 2. But this should be 1, right? Because we're supposed to swap these, so we shouldn't get 2 and 2. So because of this, we need to basically store root.left in a temp variable so that when we can basically do root.right is equal to temp. Temp, and we actually get the expected result, right? So yeah. So we're going to do tree node temp equal to root left. We're gonna say root to the left equal to root to the right, and then root to the right equal to temp. Okay, and that's how we do the swapping recursively. You have to store it in a temp variable, right, when you do the swapping. So really all we're doing is, for a given node, just swap the child nodes and then go down to the left, swap these child nodes, right? And then we're going to swap these child nodes, etc. So we're just swapping the child nodes of a given node, if there are child nodes, right? If there aren't, then we just return 0. But yeah, pretty simple problem. It's like a good introductory binary tree problem. So anyways, I hope this was helpful. But if you have any questions, let me know. I have solved this problem in Python as well. In Python, it's actually a little bit easier because you don't lose the values. So in Python, I think you can do something like this in Python, which is kind of cool. To solve this problem, you can basically do something like this in Python. But unfortunately, it's a C++, so it's a little bit different. But anyways, I hope this helped, and I'll see you in the next one.